Hi everyone, welcome to the session of ECA Electronic Circuit Analysis. In this class, I am going to give the topic, lecture on the topic, that is introduction of differential amplifier. So what is meant by differential amplifier? What are the types of gains in differential amplifier? And how we can construct a differential amplifier? What is the operation of differential amplifier? We will discuss all these topics in this topic. So those are all subtopics in the differential amplifier. In previous class, we have seen that what is meant by multi-stage amplifier, what are the advantages of multi-stage amplifier, why we are using a multi-stage amplifier, and whenever we are cascading or we are connecting multi-stage amplifiers, then what is the gain, what is the input impedance, what is the output impedance, as well as what is the effect of coupling capacitors on the multi-stage amplifier. And whenever we are connecting number of stages, what is the effect of cascading on bandwidth as well as gain. So these topics we have covered until the last session. Okay, so this is the last topic of this unit. So this is the introduction of a differential amplifier. So let's go to the topic. So first of all, what is a differential amplifier? So as the name indicates, it is also an amplifier. It amplifies the difference between the two input signals. So here we are applying two input signals. So the difference of those two input signals is amplified by the differential amplifier. Okay, already we know the definition of amplifier. Amplifier amplifies the signals. So that is, it strengthens the weak signals. Okay. So here also we are applying two input signals. The difference of those two input signals will be amplified by the differential amplifier, or is amplified by the differential amplifier. So it is very much popular, and it is used in many in variety of analog circuits. So mainly, and it is the basic building block of operation amplifier. It is the main block in the operation amplifier. Operation amplifier means it performs some operations. It performs some operations like mathematical operations, like addition, subtraction, multiplication, and so on. So differentiation. So these mathematical operations are performed by the operation amplifier, or these operations are performed by the operation amplifier. So in order to do the mathematical operations, we are using a operation amplifier. In the operation amplifier, this is the main block. Differential amplifier is the main block, and it amplifies the difference between two input signals. It amplifies the difference between two input signals. So here we have the figure or pictorial representation of differential amplifier. So if it is a differential amplifier, it consists of two input signals. One is V1 and another one is V2. So these two input signals are taken as V1 and V2. So here the difference of these two input signals is represented as V1 minus V2. The difference of these two input signals is represented as V1 minus V2. So the output voltage of the differential amplifier is proportional to the difference of these two input signals, or the differential amplifier amplifies the difference between these two input signals. Hence, the output voltage V0 is proportional to the difference of these two input signals. So that is V0 is proportional to V1 minus V2. And here we can also write it as V0 is equal to AD into V1 minus V2, where AD is differential voltage. The gain of the differential amplifier when we are applying two different signals. So this is the proportionality constants, or we can also say like that. So AD into V1 minus V2. V1 minus V2 is the difference of these two input signals. Okay. So here from this equation, we can say that the differential amplifier output is amplified version of the difference of those two input signals. That is V1 and V2. Okay. And next, here we have two types of gains mainly. One is differential gain. It is represented as AD. Another one is common mode gain. It is represented as AC. Okay. So what is meant by AD or differential gain? What is meant by AC or common mode gain? So here The differential gain is the gain with which the amplifier amplifies the difference between two input signals. The gain with which the amplifier amplifies the difference between two input signals. It is denoted as AD. Normally, it is denoted as AD. Okay. So whenever we are applying two different input signals means, like for example, V1 is 5 volts, V2 is 2 volts. Okay. So those two inputs are different, and the difference of those two input signals means 5 minus 2. 5 minus 2, that will be 3. Okay. So that means the output will be amplified version of those the difference of those two input signals. Okay. So here the differential gain represents the gain when we are applying two different input signals to the differential amplifier. Okay. When we are applying two input signals to the differential amplifier, the gain of that differential amplifier is known as AD. Okay. So here, when we are applying two different input signals, what is the output voltage? From the previous equation? V0 is equal to AD into V1 minus V2, where V1 and V2 are two different input signals. Okay. So that is V0 is equal to AD into V1 minus V2, or we can also write it as V0 is equal to AD into VD, where VD is the difference of those two input signals, that is V1 and V2. Okay. So from this equation, what is AD? AD is equal to V0 by V. So this is the differential gain. Mathematically, the differential gain can also be defined as the ratio of output voltage to the difference voltage. Output voltage to the difference. The ratio of output voltage and difference voltage is represented as the differential gain. Okay. And in decibels, we can also write it as in decibels, that is AD in dB is equal to 20 log of V0 by VD. So this is the mathematical equation we should remember when we are doing some problems on the differential gain. Okay. And next type of gain is common mode gain. Next type of gain is common mode gain. It is represented as AC. It is represented as AC. So normally the differential amplifier amplifies the difference of two input signals. Okay. And it also eliminates or rejects the common signals. So differential amplifier amplifies the difference of two input signals, as well as it also eliminates or rejects the common signals. Common signals means, suppose consider V1 is 5 volts, V2 is also 5 volts. Okay. So what is the difference? V1 5, V2 5 means those two signals are common signals, that is same signals. So if you are applying same signals to the differential amplifier, then what happens? It amplifies the difference of those two input signals. What is the difference? V1 is 5, V2 is 5, difference is 0. So that means output is 0 approximately. So differential amplifier eliminates or rejects the common signals, and it amplifies the difference of two input signals only. That is the ideal case. Okay. And in practical, what happens? We will see. So if you apply two input voltages which are equal to the differential amplifier, then ideally output voltage must be 0. So as I said, if you are applying same input signals, that is 5 and 5 to the differential amplifier, then what is the output? Output voltage becomes 0. That is the ideal case. Okay. But in practical, it is not the case. That is, in practical, we have some value. It is not equal to 0. Okay. So in practical amplifier, we have some voltage because the output of differential amplifier not only depends on the difference of two input signals, but also depends on the average of two input signals. So that means output voltage of the differential amplifier not only amplifies the difference between those two input signals, but also amplifies the average of those two input signals. So that means in ideal case, if you are applying two input signals, that means if you are applying same input signals to the differential amplifier, then ideally the output is 0. The output voltage of the differential amplifier is 0. But in practical, the output voltage of the differential amplifier is not 0. Okay. And the differential amplifier amplifies the average of those two input signals. What is the average? Average of two input signals. Suppose here we are applying V1 and V2 as the two input signals. Average of those two input signals is V1 plus V2 by 2. Okay, and we are also consider the average as VC. VC is common mode voltage. The average of those two input signals is V1 plus V2 by 2, and that is considered as VC here. Okay, this is common mode voltage. Then what is the gain? Common mode gain. So common mode gain is the gain with which the differential amplifier amplifies the common mode signals. Common mode gain is the gain of the differential amplifier whenever we are applying same input voltages. Okay, if you are applying same input voltages, then the gain of that differential amplifier is known as common mode gain. And mathematically, it is represented as the output voltage V0 is equal to AC into VC. Okay, so this is the output voltage whenever we are applying the same input voltages. Okay, so normally it is V0 is proportional to V1 plus V2 by 2. So from this equation, V0 is proportional to V1 minus V2. That means it amplifies the difference of two input signals. This is the ideal case. This is the ideal case. But in practical, it also amplifies the average of those two input signals. So that means V0 is proportional to V1 plus V2 by 2 also. Okay. And the proportionality constant here, we are representing it as AD. In that case, that means whenever we are applying the same signals, then we are the proportionality constant is taken as AC. So that's why V0 is equal to AC into VC. And what is VC here? VC is common mode voltage. So that is average of those two signals. So that is V1 plus V2 by 2. So V0 is equal to AC into V1 plus V2 by 2. And from this equation, what is AC? AC is equal to V0 by VC. AC is equal to V0 by VC. V0 is output voltage, VC is common mode voltage. Okay. So this is the mathematical expression for the common mode gain, and mathematically we can also define as, that is, the common mode gain is also defined as the ratio of output voltage to the common mode voltage. Okay, and finally the total output of differential amplifier is given as V0 is equal to AD into VD plus AC into VC. This is the practical case. In ideal case, we have only, that is, we have the equation V0 is equal to AD into VD only in ideal case, because in ideal case it suppresses or it rejects the common signal, because this will be 0. It does not allow the common signals, and that means the output will be 0. But in practical, we have some average, that means amplified version of the average signals, average of those two signals. So that's why the output voltage is the summation of AD and VD and AC and VC. AD is differential gain, AC is common mode gain, VD is difference voltage, VC is average of those two signals, that is common mode voltage. So this is the output voltage of differential amplifier in practical case. Next one. Next definition we should remember. This is also one of the parameter of the differential amplifier we should consider. So that is CMRR. CMRR means the full form is common mode rejection ratio. Common mode rejection ratio. So what is meant by CMRR? So CMRR is defined as the ability of the differential amplifier to reject the common mode signals. To reject the common mode signals. It is defined as the ability of the differential amplifier to reject the common mode signals. So by the value of CMRR, we can observe, or we will know that how much amount the differential amplifier can amplify the difference of those two input signals. Normally, the differential amplifier should amplify the difference of those two signals only, and it rejects the common signals. It rejects the common signals. So, how much amount of signal is amplified? That means the different signal is amplified by the differential amplifier, and how much amount of the common signal is rejected by the differential amplifier can be observed by the CMRR value. Okay, so it is defined as the ability of the differential amplifier to reject the common mode signal. to reject the common mode signals. How much amount of the signal is rejected, common signal is rejected by the differential amplifier, and how much amount of the signal, the different signal, is amplified by the differential amplifier. Okay, so that will be observed by the CMRR value. In other words, it is also defined as the ratio of differential mode gain to the common mode gain. Mathematically, we can also say that the CMRR is represented as rho. So rho is equal to the ratio of differential gain to the common mode gain. This is the formula for the CMRR. Okay, so it is used to calculate the output voltage of the differential amplifier. And by the value of CMRR, we will find out the amount of the different signal, as well as the amount of the rejection of common mode signal. Okay, the next one, transistorized differential amplifier. So how we can construct the differential amplifier? Suppose if you want to construct a differential amplifier, then what are the rules we have to follow? Okay, so that is, here we are constructing the differential amplifier by using the BJTs, that is transistors. So that's why this figure or this topic is known as transistorized differential amplifier. So in order to construct a differential amplifier, okay, in order to construct a differential amplifier, here we are following some rules. So what are the rules? So here we are taking two emitter bias circuits. This is one emitter bias circuit. This is another emitter bias circuit. Emitter bias circuit means here we are applying the DC voltage to the emitter also. Emitter is also biasing. Okay, so this is one emitter bias circuit. This is another emitter bias circuit. In order to construct a differential amplifier by the use of transistors, we should use two emitter bias circuits. Okay, so when we take two emitter bias circuits, in order to connect these two circuits, we should follow some rules. Okay, so what are the rules here? So here we are taking two transistors, Q1 and Q2. Okay, the two transistors have exact characteristics, that means matched characteristics. Exactly, these two transistors are matched transistors. That is first. So that means the characteristics of Q1 and Q2 must be same, and those transistors are also called as matched transistors. So first rule is whenever we want to construct a differential amplifier, that means the characteristics of two transistors must be same. Okay, that is the first rule. And second rule is the collector resistances, that is RC1 and RC2 are equal. The collector resistances RC1 and RC2 are equal. So that means if you are taking some 1 kilo ohm as RC1, here also we should take RC2, that is, it is also 1 kilo. Okay, so these two resistances must be same. And similarly, RE1, RE2 must also be same. That is, if you are taking some 1 kilo, this will also be 1 kilo. Okay, so these two transistors must be same. Sorry, resistors must be same. Emitter resistance must be same. Collector resistance must be same. That is RC1 equal to RC2, RE1 equal to RE. And next rule is the magnitudes of VCC and VE are also same. The magnitude of VCC and VE are also same. So that means here if it is 5 volts, this also be 5 volts. That is, if it is plus 5 volts, this is minus 5 volts. The magnitude, that means VCC and VE must be same. That is the third rule. Okay, first rule is transistors must be same. That is, these two transistors must have the same characteristics or matched characteristics. And next, the resistances, collector resistances and emitter resistances should be equal. And third rule is the magnitude of DC voltages, that is VCC and VE must also be same. So these rules we have to follow. And next, in order to construct a differential amplifier, first the differential amplifier is achieved by connecting the emitter of E1 of transistor Q1 to the emitter of E2 of transistor Q2. So due to this, the Re1 appears in parallel with Re2, and the combination of these two resistances is replaced by a single single resistance, that is Re. Okay. So here, in order to develop a differential amplifier or construct a differential amplifier, we should connect two emitter resistances. The two emitter terminals. That means E1 and E2 must be connected. Okay, if you are connecting these two emitter terminals, then we have these two resistances are in parallel combination, and the parallel combination of Re1 and Re2 is taken as one resistance only, that is Re. Okay, and next one, the base B1 of Q1 is connected to the input of first transistor, while base B2 of Q2 is connected. That means we are applying some voltages, supply voltages. So here, the supply voltage VS1 is connected to base B1, and the supply voltage VS2 is connected to B2, that is base B2. So here we are connecting these two emitter resistances. And next one. So whenever we are connecting these two emitter terminals, we have the parallel combination, and that parallel combination is considered as one single resistance, that is Re only. And next we are applying the input signals to the two bases of two transistors. So VS1 is the input voltage we are applying to base B1, and VS2 is the input voltage we are applying to base B2. And next one, so here let us take the figure. So first rule is we are connecting two emitter terminals. Whenever you are connecting two emitter terminals, then we have a parallel combination, that is Re1 and Re2. The parallel combination of Re1 and Re2 is taken as a single resistance, that is Re1. And next, we are applying two inputs for base B1 and base B2 for the first transistor as well as second transistor. VS1 is applied to base B1, VS2 is applied to the base B2, and RS1, RS2 are the internal source resistances. And next, we are connecting the VCC supply of both the transistors. Okay, we are connecting the collector terminals also. That means we are connecting the collector terminal of first transistor as well as the collector terminal of second transistor together. So here we have a connection like this. Okay, so this is the differential amplifier. And this one also called as DIBO differential amplifier. DIBO means dual input balanced output differential amplifier. So why we are calling it as DIBO? Means we are applying two inputs, dual input. Dual input means two inputs. So first input is connected to the first transistor, and second input is connected to the second transistor. So that's why we are applying, here we are applying two inputs. So that's why we are calling it as dual input. Next, balanced output means if you are taking the output voltage between two collectors, that means here if you see the figure, so here we are taking the output V0 between these two collectors C1 and C2. So this type of output is known as balanced output. Or double-ended output or floating output. When the output is taken between two collectors, none of them is grounded, then it is called balanced output or double-ended output or floating output. So here we are applying two inputs and we are taking the output between two collectors. So hence this type of differential amplifier is known as dual input balanced output differential amplifier. Okay. So by following these three rules, that means by taking the mature transistors and by taking the resistances as the same resistances, as well as by taking the supply voltage, that means DC voltages as the same voltage, that is magnitude of VCC and VE as same, then we are connecting the collectors of two emitter bias circuits together, as well as we are connecting the two emitters of two transistors, and we are applying two inputs to bases of two transistors, and we are taking the output between two collectors. Okay, so in this manner we are constructing the differential amplifier, and this is the final differential amplifier construction. And this one is also called as DIVO, differential amplifier, dual input balanced output differential. Okay, so thank you.